Today we are going to be talking about how to find domain and range of continuous functions with arrows. Notice how all of these lines have arrows on them. This means in the direction the arrow faces, the function goes on forever and ever and does not end. Because it doesn't end in that direction, there is no limit. And we're going to see how that affects our domain and range. So let's start off by finding the domain of this graph. Remember, domain works with the x values. So we're going to look at the x-axis. We start our domain notation with putting an x in the middle with inequalities on both sides. Working from least to greatest, we're going to work from left to right. So starting at the left, we ask ourselves, do I have an endpoint or do I have an arrow? Here, the left side of this graph has an arrow, which means it goes on forever and ever. It never ends as we move to the left. So because this graph doesn't end, we can erase the left side of our notation because there is no limit that we could put there. Then we move to the right and we ask ourselves, do I have an arrow or do I have an endpoint? Here at the right side, we have an endpoint. So we're going to follow it up to the x-axis, see what our x value is. Here, this point hits the x-axis at a positive 4. So we're going to fill that into our notation. And then we ask ourselves, do we include the 4? Is 4 included in our domain? We look at the endpoint. Notice how the endpoint is a solid circle. It is shaded in. Because it's shaded in, we know that yes, it is included. So we can draw a line underneath our inequality symbol. And our final answer here is our domain is x is less than or equal to positive 4. This means x is any value equal to or less than 4. One way we can check our work here is by looking at the inequality symbol. Notice how the inequality symbol kind of looks like an arrow pointing to the left. Well, if we look at our graph, notice how our arrow is also pointing to the left. That's one way we can check our work. Here we want to find the domain of this graph. Remember, domain works with our x values. Working from least to greatest, we're going to start at the left. Do I have an arrow pointing to the left or do I have an endpoint? Here we have an endpoint at the left side of our graph. So we see, where does that endpoint fall on the x-axis? Here our value is -2. Is -2 included in my domain? Because that endpoint is an open circle, it is not filled in. We know that -2 is not included in the domain. So here we will not have a line underneath the inequality. Let's look at the right. Do I see an arrow or do I see an endpoint? Here I see an arrow at the right side of my graph. So I know that my graph goes on forever and ever in this direction and never ends. Because of this, I don't have a limit, so I can erase the right side of my notation. Finally, we want this to read from left to right like a sentence. I need to rewrite this to have my variable on the left, my constant on the right. I need to flip my inequality sign in the middle. And I say x is anything greater than -2. Again, I want to check my work. I look at my inequality symbol. Notice how it looks like an arrow pointing to the right. I look at my graph. Do I see an arrow pointing to the right? Yes, I do. So I know that I checked my answer. I know that I'm right. X is anything greater than -2. Here we want to find the domain of this graph. Remember, domain works with our x values. So here we want to work from least to greatest. So starting at the left, do I see an arrow pointing to the left on this graph? Yes, I do. Be careful, because now we're not looking at the endpoint. We want to see, is there an arrow that points to the left anywhere on this graph? And yes, we see one. Because of this, we have no left endpoint, so we can erase it in our notation. Now I need to find the farthest right I can go on this graph. Do I see an arrow that points to the right? I don't have an arrow that points to the right. Instead, my farthest right point hits the x-axis at +5. Be careful here. It's not the endpoint, it's the farthest right we can go on this graph. Is +5 included in the domain? Because this is a solid line, yes, +5 is included. So we draw a line underneath our inequality. And here we can say that x, our domain, is anything less than +5. Again, we can check our answer by looking at the inequality symbol. Our inequality symbol looks like an arrow pointing to the left, and we see an arrow pointing to the left on our graph. So we've checked our work, we know we're right. X is anything less than or equal to +5. Now let's talk about how to find the range of a graph with arrows. It's the same idea as the domain, but instead of working from left to right, now we're going to be looking for arrows that point up and down. Let's find the range of this graph. First thing we're going to do is set up our range notation. Remember, this has a y in the middle. So here we want to work from least to greatest. When we're talking about the range, our y values, we're going to be looking at the y-axis. Here, the smaller numbers are at the bottom of the graph. So when we work from least to greatest, we're going to be working from the bottom to the top. So our first question is there an arrow at the bottom, or is there an endpoint at the lowest point we see on the graph? Here, our lowest point is an endpoint. So we're going to follow it over to the y-axis. And we're going to say this endpoint hits the y-axis at -2. Is -2 included in my range? Because that circle is a solid circle, it is filled in. I know that yes, -2 is included. So my inequality sign is going to have a line underneath it to represent equality. Is there an arrow that points up? Yes, I do have an arrow that points up. So I know that there is no upper limit. I can erase that on my range notation. Here I am left with -2 is less than or equal to y. So I have one final step. I want to rewrite this so that my inequality reads like a sentence. So I need to rewrite it so that my variable is on the left, my constant is on the right. Remember to flip the inequality sign in the middle. So here my inequality is y is greater than or equal to -2. Here my range is any y value greater than or equal to -2. So here let's look at the graph, let's check. Our graph starts at -2 and we get higher and higher, we get bigger from there. So yes, y is anything greater than -2. Let's try one with a curved line. We want to find the range. So that's our y values. So we're going to look at the y-axis. Working from least to greatest, we're going to start at the bottom and say, do I see an arrow pointing down? I don't see an arrow pointing down. I see an end point. Notice how this end point hits the y-axis at -5. So I can fill in -5 to the lower limit. Is -5 included in the range? Because this is a closed circle, a filled-in circle, yes, -5 is included. So we're going to write a line underneath our inequality. Then we look up. Do I see an arrow pointing up on this graph? I do. That means the graph goes on forever and ever, and there is no upper limit, so I can erase it. So we're left with -5 is less than or equal to y. The last step would be to rewrite this with our variable on the left, our constant on the right. Remember to flip your inequality sign. Here we say y is greater than or equal to -5. Let's check our answer. Working from the bottom, we start at -5 and we only get higher, we only get bigger. So yes, our range is any y value greater than or equal to -5.